but today, rather than using the for loop to do repetition, we're going to be using it to iterate over something. Technically, we've been doing that the entire time, but let's go ahead and take a look at today's, at what we've got today. So today we've got computing statistics with Kiva data. So very, very basic start to kind of doing some data analysis and data science, but we can't really get there yet because we won't really be able to get through all this in the amount of time that we have. But if you're interested in continuing on with that, you can find that this is going to be very useful practice. Again, to get here, either look in Discord, look here on the under modules, then go to module 4 and the module 4 overview over here for lectures, or just simply go to the Runestone book. And once again, scroll all the way down over here to Project 6, Computing Statistics with Kiva. So, what we've got here is a table from Kiva. Kiva is a nonprofit. They are an anti-poverty nonprofit. What they do is that they are a microloan service. So let's go ahead and open up Kiva and take a look at them. Okay. So the idea here is that basically you hand money over to Kiva, about $25 is their small unit, and then you can direct where that money goes in the form of a microloan. Note that these loan amounts are not particularly big. That's the entire point of these. These are not particularly large loans, $775, $200, and they are loans, meaning that they are intended to be paid back. And the idea here is that you will loan out your $25 or however much you donate. They loan this, it gets loaned out to them, they pay it back over time, and then they will fully repay those $25 you have given to Kiva. And then you use that money again to make another loan. So it just keeps that money keeps recirculating essentially in the form of a loan. They try to make it interest free where they can, but they have to sometimes work with local lenders. So, they provide a service that that was not available when they were founded essentially. And now they've been around since 2005, and they've made quite a number of loans. So, and so you hold on to that data because it's financial records. And when you hold on to data, suddenly you'll have a whole lot of data that you can analyze. Now, typically, this kind of stuff is anonymized when you go and analyze it. By which we mean, hey, you've got an ID, which Kiva, who has all the rest of the data, can look up and say, oh, this ID went to this particular person, but for our sake, we don't need it. Instead, what it tells us, we have the relevant columns, right? Rather than having their name and other personal information, we don't really need that to do data analysis. What we have is other things. So what we've been provided here for data analysis is 50 rows out of a data set that contains 1.4 million rows. And that was years upon years ago. So probably they have way more data now. But what does this contain? It has the loan amount, the country name, so how much money was the loan for, the country name, the status. These are all funded loans, so basically was it funded, partially funded, unfunded, whatever. I don't know if what the other status is going to be besides funded. Since they're all funded, we can ignore that one. Time to raise. This is probably in seconds, I would almost guess. Certainly not milliseconds because that would be because this would be funded in minutes. But time to raise, we can always ask for the unit. That is one of the disadvantages about floats. About not having to care about units is sometimes when you are handed data, you're like, what was that unit? I have no idea. So you have to make assumptions. And then finally, num lenders total. how many people gave money to that particular loan, right? There's probably other data that says, hey, we have a list of all the loans, of what each individual loan was, but that's not in this provided data. And we can see here that this loan for $1,250 went to somebody in Azerbaijan, and it was 38 people funded that. Wasn't equal amounts, right? Because necessarily. Yes.
But it was lumped down
to a single person, or possibly that person's company, or something like that. So, but one applicant, let's say. Okay. Similarly, somebody in the Philippines, that was a $100 loan that was completely funded by one person, right? And this other one in the Philippines for $150, one person again. So this, you can't really make too much of an assumption about how much that loaned out. But again, we can kind of. So we take this data, and typically what you do is this will come in a large text file of some kind, right? Or an Excel spreadsheet or CSV file. We'll be working with CSV files much later in the semester. But the idea here is that you will get this file, and you want to basically render it into some form that you can do for data analysis. We are going to just simply get that stuff, right? Get that set up for us. This code block over here, you don't need, I would run it just simply so that you get the interaction with it. I don't think I score it, but just in case. The idea here is that this code over here will automatically be included in all the rest over here. It's kind of, when I write problems for the textbook, or other people write problems for the textbook, we can sometimes make hidden code, such as unit tests and other things, just simply to keep stuff out of the way of students and to kind of show them what. But anyway, you'll see that basically, normally if I were over here and went print this, it would say, what you doing? It's not defined. In this case, over here, in this case, over here, if I print that field, it will actually run, because that field is defined. It's just kind of invisible, so we don't have to redefine these each time. You'll also notice that this one has unit tests. Unit tests, if you haven't seen them in your textbook yet, basically are bits of Python code that test your code. And it looks for some things, for saying, hey, you need a loan total variable in this particular problem. But let's look at what this is first. What are these four variables? Well, note the columns over here: loan amount, country name, status, fund, time to raise, num lender's total. Loan amount. First loan is $1,250, $500, $1,450. $1,250, $500, $1,450. So what's going on here is that the author has already put these columns into a list for us. They've kind of taken these columns and kicked them over, so to speak, so that they're laying horizontally rather than vertically. Make sense to everybody? Right? As a result, you've got Azerbaijan, El Salvador, Bolivia. You've got time to raise and num lender's total. So we have all of these items, right? And we know that all of these first items, the ones that index 0 for each of the lists, these are all basically the same loan, right? These all pertain to the very first row in the list. Whereas the items at index 1, the second item on the list, right? Because we start counting from 0. Index 0, index 1, a $500 loan from El Salvador. It took 11 and 5, 7, 108 time to run, and then 18 people funded it. And we look at this, $500 loan from El Salvador, same numbers over here, right? So these all go together. These are paired together. They're kept in the same order. Now, So we've got some very basic, so we're going to try to answer some very, very basic questions in the grand scheme of things in terms of what the data can tell us. So the first question is, what is the total amount of money loaned? For this, we'll need to use a for loop. I mean, actually, technically, you don't need to use a for loop because you can do stuff like sum. And that's built into Python. Like, for instance, sum of loan amount will give you the total amount of money that has been raised over those 50, but it will yell at us, right, loan but will yell at us and say, hey, you may not use sum, because they want us to actually use a variable. So let's actually look at what the problem says. Compute the total amount of money loaned and store it in a variable loan total, right? And they don't want you to use the built-in, we want to use practice for loops. To do this problem, we're going to need to use the accumulator pattern, and we're going to need to use the other way a for loop works in Python, which is to iterate over something, right? Okay. Come on. There you are. All right. Let's go to Documents. Let's go to GitHub, Classroom, Intro, Iteration. Okay. So we've seen the for loop operate like this. And this gives us the numbers 1 through 10. Sorry, 0 up to, but not including 10, not 1 through 10. It gives us 10 numbers, 0 up to, but not including 10, right? 0 through 9. Right, we've seen this one already. We saw it last week, right? Now, technically, what is happening here is that range is giving us a sequence of numbers to iterate over. It's giving us a sequence of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's allowing us to iterate over them. Technically, for those of you who are going to be pedantic about it, I'm simplifying this. This is actually something really complex called a generator, but you don't need to know about that. All you need to know is that this gives you a sequence of numbers. You'd have the same effect if we had a list of numbers. In fact, you can use a for loop to go over any sequence. So let's say we've got some numbers over here. 1, 3, 5, 7, 6, 2, 4, right? Thought I was going to do some odd numbers. Now let's change things up. What you can do is we mentioned that this can change. And it's always for blank in blank, right? For x and y. Well, the x is always a thing for the thing in the sequence, the thing in the collection, for the individual unit in the big pile of stuff we have. So here we can write for I in nums to go through each of these numbers individually. 1, 3, 5, 6, 7, 6, 2, 4. Similarly, word is equal, right? Here we go. Left word. Not Control F, but replace that, and then we go and run it. And this is a string, THIS space IS, right? It's going through for each individual item in Word. Although in this case, I might want to rename it like for letter in Word, right? The variable is whatever you want its name to be, so long as it matches what you're going to be doing, right? Yes?
What if you put nums for I and then range for y? Like, is it interchangeable?
No, like if I did this for nums in range, yeah, here's what would happen. You'd be overwriting you'd be basically, so nums over here saves a reference to this list. Basically, it saves a memory reference as to where to find this list. Basically, for all intents and purposes, it stores the list. Then when we get over here, this going through the for loop says, let's set nums equal to the first item in the range. So we're going to take 0 and store it in nums. Then we're going to take 1 and store it in nums, and 2 and store it in nums. Not the list in nums, but actually like overwrite the actual thing stored in nums, right? So that's what's going to happen there. You can reuse variables all you like that in Python, and other languages don't allow you to do that for safety's sake. But Python's flexible and allows you to do stuff like that. But basically, this is a variable that's going to get redefined every time we iterate over the loop. So there's a couple ways. So what we're going to see is that there's a number of ways to go through each of these items. How many of you have gotten through the textbook and gone through indexes yet? Like understand what the index of a string is, the index of a list? Yes? No? A number of you have. Awesome. Right? I was mentioning that earlier. The index is simply position in the list or in the string. 0, 1, 2, 3, 4, 5, 6. So if I were to say, hey, so we've got THIS. What is the thing at index 3? And that's how you say what is the thing at index 3. You use the collection, open bracket, the item that you want, the index you want, and then close the bracket, and you run it. It will say S. And it's giving me this S. Let's see, we only see an H once, so just to be sure, we can put in 2 over here. Right? Or not 2, 1. There we go. So that's another, so the other classic way of doing things that's more what we do in the other languages you'll see is iterating over the indexes and changing the indexes and just manually grabbing everything from the list that way. That's still a way you can do it. So now that we have this tool to use for X in Y, right? Let's go ahead and use that to compute the total number of money loaned and store it in the variable loan total. And what you want to do this problem is create an accumulator, right? They said stored in the variable loan total. So that's the variable that you're going to be putting stuff into. So start that off at 0. Then go through your individual loans and add each of these amounts to the loan total. Make sense? So the first question is compute the total amount of money loaned and store it in loan total. You don't actually need to print it out at any point because we're just trying to get through this test. Okay. So I'll give you a couple minutes on that one, and then you can. And then we're going to see. Then I'm going to do this one to death because I'm going to show you multiple ways we can do this. All right. So let's see. So let's go ahead and do this one now. So to do this one, we need to do the accumulator pattern. What we're going to do is it says we want to store the total amount of money loaned in loan total. And so we need to set that at 0 because that's how much there's going to be to begin with. Run. So we need to, and then this test tells us we need to somehow get the right answer, right? Of course, some tests are easy and you can just cheat them. But some of the other tests and other projects are more advanced and do actually look to see, did you write a for loop? So let's actually write that for loop. Okay, let's actually figure out what that is. So the idea here is for loan in, so let's say for A in loan amount, A for amount. For every amount in loan amount, what are we going to do? We are going to say, hey, loan total is equal to the current value we have for loan total plus A, the amount that loan is. And believe it or not, that's it. That's all we need. Okay. The next step is to use that to calculate the average. But I do want to say that there's more than one way to do this before I go on. Okay? The other thing you can do is you can individually go index by index. Okay? You can individually go by index by index. And this is how you might do it if you're coming from a previous programming language. You might go for I in range. And 0, well, we automatically start at 0, so, and then say len loan amount. Len gives us how big that is. How big is, how big is loan amount? Loan amount, in this case, is 50, so it's going to replace this with 50. So for I range 0 to 49, which is all the valid indexes in the list. Make sense? And then they'll do something like this. A is equal to loan amount I, and then we can just simply copy this line over here. So we grab the amount at that index, stored in I, and we add it to the loan total. These two are identical in terms of functionality. Make sense? The first way is typically how you do it in a lot of programming languages like C, C++, Java. However, for Python, this is the correct way to do it over here, or the more correct way, or it's more succinct and it reads much more naturally, right? You want to do the range function over here, this range length thing, if you know for a fact you care about the index that things are in. And we will care about that in a bit, but not quite yet. So for the next part, compute the average amount of money loaned and store it in the variable loan average. So let's go ahead and say loan. So we know we need a loan average. Loan average. I'm just going to say it's equal to 0 for right now, because I don't like just simply leaving fragments of code that don't run all around. So what do we need to do to calculate the average? How do you calculate the average of anything, right? Anyone? I guess everybody's pretty shy today. I know you all know how to calculate an average. An average is just simply the sum of all the items divided by the number of items you had just added up, right? So if you want to know the average grade in class, I'd take all of your grades, add them up, and then divide it by the number of people, right? So if I had 100 students, I'd take all the grades on an exam, add them up, divide by 100, and that would give me the average. 100 if there were 100 students. If there were 101 students, obviously I would divide by 101. So to calculate the average of the average loan would be, we would need the loan total, like we had above. Loan total is equal to 0. And then we would need num loans, the number of loans that were made. Okay? Now, there's line 4, which is figuring out the number of loans, that's actually fairly easy to figure out. You just ask, hey, len of loan amount. What was loan amount again? That's that big list, right? That we iterated over. We can just simply say, hey, this is how many loans we have. Loan total will calculate the same way, right? We add up all the numbers to get the sum, then divide by the number of loans. So loan average would be the loan, once we're done, the loan total divided by the number of loans. Make sense? Now, obviously, right now, this is just going to give me 0 because I say loan total is equal to 0. Then I say the number of loans is equal to 50, and I say 0 divided by 50, store that in the loan average, right? I don't actually do the calculation yet, right? What I have to do in this case, again, is use the accumulator pattern just like we did above. For A in loan amount, loan total is equal to loan underscore total plus A, right? So for this will take a bit, but hey, let's run it, see it in code lens, right? You can see here if we see it in code lens that we have a bunch of that, all that code was just hidden. So it declares this code. And you know, I love this. It shows us like here's the loan amount, here's the country name, time to raise, number of lenders. Loan total is equal to 0. Number of loans is equal to 25, so not even 50. Okay. So for A in loan amount, right? What it's going to do is that it's going to look at the first item in our loan amount list and store it in A, and then we take that value and add it to the loan total. We just saw that update right here. Then we look at the next value. All right, give me a second. Give me a second. How do I make this bigger? Can I make that? No, let's go ahead and just simply edit code over here. That'll work better. Okay, there we go. That way I can actually step through it and there we go. So here we have 1250. Then we go to 500, we grab 500, add that to the loan total, then we go to 1450, add that to the loan total, and so this number just keeps going up. So let's go, so this one's going to be easier to see because it's a small number. 200 added to 3,200. That's what's about to happen. That's what the red line says is about to happen, right? Because loan total is 3,200 currently. A is 200 because that's the next item in the list. We're just going through the A is just going to be these values sequentially. It's going to vary because it's the variable. And we add it and it becomes 3,400. Then 700 and so on and so forth until it goes all the way through. Once we're done adding, we go on to loan average is equal to loan total, which is 16,575, what we computed last time, divided by 25, the number of items in the list. For some reason I thought it was 50. Then divide by 663, divide those two and you get 663. Let's go back to run it and we see, right, this is the expected value. So this is probably the trickiest of the bunch, I would say, because it requires us to use a bunch of functions that we may not know exists. But we're still dealing with loan amount for the first part of this. Store the amount of minimum loan in min loan and the amount of maximum loan in max loan, okay? So we're going to find the minimum, the smallest loan, and the biggest loan. Make sense? Then store the name of the country that received the largest loan in max country and the smallest loan in min country. Hint, max and min are built in Python functions you can use to find the minimum value or the maximum value in any sequence. Okay. A lot of times, though, when you don't know how to do something like this, you need to kind of think, how would I actually go about this? And we'll see that in a second. So to find the minimum value, what I would normally have to do is I would have to look through the loan amounts and kind of see, 100 is the smallest, and I don't see anything smaller than that. But we haven't learned if statements yet, which is kind of what you need to do for that. Fortunately, Python provides these wonderful functions called min and max. Min of some list, right? 1, 2, 5, 7, -12, 15 will provide, if I ask for the minimum of some list or something, or some other collection, it's going to give me the smallest item, right? In this collection, -12 is the smallest, right? So minimum gives me the smallest of any collection. This also works on strings, oddly enough. Min of thing is G. Any idea as to why it might be G? Let's go ahead and take a look at another one just so that we don't, because otherwise you might make a faulty hypothesis. Apple gives us A. Min of apple gives us A. Any hypothesis as to what min is grabbing here? Yes. Yes, somebody shouted out alphabetical order. Gives us the smallest thing, alphabetical order. Max does the exact same thing, which is gives you the biggest thing. Here, the biggest thing is the furthest into alphabet, which is P. Here, likewise, this would give us the biggest number in this list if I change this from min to max. 15, right? So it gives us the biggest thing, which is super useful. So over here, we are going to do min loan is equal to min loan underscore amount. And we can run this and see that it works. And it's going to say, hey, you figured that out. Don't be afraid to use the hint. Then it's going to say, hey, you didn't do the max loan thing. Right? Max underscore loan is equal to max loan amount. Find the biggest loan, find the smallest loan. So those are 100 and 800 for the smallest and biggest, respectively. And now the next part. Then store the name of the country that received the largest loan in max country and the smallest loan in min country. Now, how would I go about doing that? Well, first off, let's think about how I would actually do this if I were actually trying to do this by hand. So let's take the information we're given and try to find. So the largest loan, we want to find the country that had the largest loan. We've solved that the largest loan is $1,800. So if I were doing this by hand, I'd go up to this list of numbers and I'd look. Where is the loan amount? I'd go from, let's be pedantic about explaining what I'm going to do. I'm going to start at the top of this list and I'm going to look for this number. I'm going to go through this list of numbers and look for the number, aha, 1,800. I found it. That's the maximum load. So what country is that? Georgia. I find that out because I know that all these things are the same loan. So at 1,800, the country is Georgia. Same thing for the smallest loan. I'd go through and I'd look, is this 100? Yep. And so when I see 100, I'd go to the Philippines, right? So what am I doing? Let's try to think about this in computer terms over here. I'd go and I'd try to find out, okay, if I can find 1,800, then all I have to do, that's going to be at a certain index. Let's call it index I, okay? That's going to be at some location in the list, index I. What I can then do is that I can take that same index and grab the corresponding country from that index. So over here, right, it doesn't line up because they're not going to line up visually because they're all different lengths of kind of entries, right? We have country names tend to be a lot longer than these numbers do. So, but that's what we did over here. We just simply looked and said, aha, give me something in the same row. So the things in the same row have the same index. So the question becomes, how can I find out what index this is at? Anyone know? No? So what we've got here is a tool. For any list, like loan amount, in this case, well, actually, I'll just simply put .index over here to remind you. For any list we have, such as over here, I can say, let's go with words is equal to, I'll make a list of words. Hello, apple, banana, grape, better, banana. Why not? Okay, so I've just made a big list of words. Doesn't really matter what it is for the purpose of the demonstration. If I then ask it for words dot index, I can ask for the index of something. So I can say, give me the index that corresponds to apple. And it'll say index 1. If I ask for banana, it'll say, you can find banana at index 2, index 0, index 1, index 2. If I ask for better banana, which is different, it's a completely different thing than a banana, apparently. It's going to be index 4. And as a heads up, right, if I look for something that doesn't exist, it will tell me, hey, that thing doesn't exist. I guess that's an error. And if you look for something, that has a repeat, like apple, it will return the first, it's going to be lazy and say, oh, I'm just going to find the first thing I can and tell you where it is that matches, right? The first thing that matches. Okay. Fortunately for us, all of our loans are unique here, so you can use index so this is kind of a two-step thing here, right? So the first thing is we need to find index of the number, the min, max, loan amount, right? That's the first step to this. And then the second step is to use that index to grab the country name. All right, take a minute to do that on your own. That shouldn't take too long if you've been following along, and if not, well, then just wait for my explanation. No for loops required in this one, right? Just simply using the list operations here. is the issue with the mask. All right. So the first thing we wanted to do was find the index of the specific number. So the minimum or maximum loan. And again, the important thing here is that you're trying and you're thinking about it. If you didn't solve it, that's fine. I just need you to start thinking about it and engaging your brain. Okay? You know, just so that we can actually get stuff done and within a time limit, I have to cut it off. So find the index of the number. So I'm going to create a variable. We could ostensibly just do this in one step and I'll show you that in a minute because it would look ugly. But there's a very important kind of concept that you'll see, which is that code is read a heck of a lot more than it's written. So it's worth it to you to write it in a way that's easy to read. Sometimes that is just, unless you're really, really, really trying for optimizing stuff, then readability trumps it. So min index. So we're going to find the index of the number. Let's go and we're going to start with the minimum loan first. It's equal to, so we're going to look in loan amounts for the dot index, the min loan. All right, and that will tell us where this index is. So I'm just going to print it out. We don't need to print it out. I'm actually going to delete that as soon as I'm done with running this. Right? Print, and it will tell us 5. It's at index 5. And if we look at our list, 0, 1, 2, 3, 4. Let's see, that's not over here. Let's look at this list over here. 0. Oh, we're looking for minimum, not maximum. I'm looking for my eyes were looking for the minimum, for maximum. 0, 1, 2, 3, 4. Index 5 is over here. Likewise, if we look over here, index 0, 1, 2, 3, 4, 5. So that's correct. Now what we're saying is that we want to get the name of the country at index 5 because that's going to be min country. 1, 2, 3, 4, or sorry, not 1. We start at 0. 0, 1, 2, 3, 4, 5. Philippines. Min index is equal to this, and now. So what we're going to do is we're going to say min underscore country is equal to not loan amount, but country name. Why country name? Before I finish typing it, why country name? Because the countries are stored in country name. That's why. Names of the country are stored in country name. Personally, I would have preferred him to plural, or the author to pluralized it, right? Because country name sounds singular, but that's just my personal preference, which is, again, preference. Country name, min underscore index. And that's going to store that, so it's going to say, hey, grab from this minimum index. What is min index? It will be 5. So country name, index 5, give me that what's ever there and stored in min country, which is Philippines. Then, the wonderful thing about this code over here is with min and max, you can really just copy paste it, and then all you have to do is almost all the time, all you have to do is, if you have lesser thans, you replace them with greater thans. If you have greater thans, you replace them with lesser thans. And then you replace all instances of min with max and all maxes with mins. It's just swapping one with the other. So over here, all we had to do for this problem is swap min and max. Right? The max index is equal to where we find the max loan. Then we take that max loan and store it. And let me delete these comments so at least this statement looks less visually cluttered. And then we can do pop. which is the correct way to do it. I'm partial to doing it above, but some students like putting the comments over here. I don't think there's a particularly wrong way, but I just like my lines to be short. But this way, at least the lines you care about, they're not visually cluttered, right? Step 1, grab the index. Step 2, use the index to grab the name. Now, what I was talking about readability is that there is a way we can do this to do it in one line. And it looks like this. Brackets are just another type of parentheses as far as PEMDAS is concerned, right? Parentheses or brackets, right? So that's what's going to go first. So it's going to say, aha, figure out what's inside the brackets. Well, what's inside the brackets is a function call. What's inside here? Well, so we'll figure out max loan, then we'll do the dot index operation on loan amount, then we'll take the variable. But look, this makes me, I don't like this, right? It's a lot more complicated than it needs to be, right? There's something to be said about, having about having shorter lines. And I am a big hypocrite in this, at least when it comes to writing actual text. I'm terrible at making short sentences. My sentences are typically like a paragraph long, because I'm very wordy, or at least it feels like that. And I'm a abuser of the semicolon and em dash, and parentheticals and footnotes. So I get so I say a lot in a sentence. But here, when it comes to actual coding, I like to make my statement succinct, even if it does make my code a bit longer, because it's easier to read, easier to debug. First off, on my perspective, when I say I'm writing this code and it's going to be read a lot more than it's written, I mean that literally, because I'm writing it over here and you're all reading it. But for you, it's also true because you're going to write that code and you're going to keep looking at it, and looking at it, especially if you're trying to debug it to figure out where you went wrong. So you're going to be reading that a lot, and you'll want to, make it easy for you to read and not have to remember, wait, what does the variable A do? You want to give yourself meaningful variable names. And especially, even more irritating, is that you might come back to this code your code you write a week later, and you'll look at it and go, what was this madman or madwoman doing here? Who was this person? How could I be so dumb? How could I be so obfuscatingly dumb? It's very easy to kind of just, it's amazing what an entire week of distance will do to, like, forgetting your stream of thoughts and how you were working on it. It's going to be very hard for you to keep track of that. So I'm going to go ahead and share this code, just simply so that you have it as a reference. Oh, max country not defined. Run it. Now, there we go. Now this sharing will be better. Boom. Okay. So now that you've had a bit of a palate cleanser, compute the average number of lenders per loan and store it in the variable average lenders, the number of average lenders per loan. Now, just as a heads up, just to remind you, num lenders total, that is the number of lenders for each loan. So you're computing the average of this. So we've already done the average once. So now that you had your palate cleanser of a completely different problem, try to tackle this one.
One second.
Okay. So this code is pretty much exactly the same as this code, right? We just had a bit of a big intermission in between that, so it may have been easy to forget. But this one calculates the average loan amount, What we're being asked to do is calculate the average of the number of lenders. the average number of lenders per loan. So in other words, the first problem that first problem I just brought up tackled the average of this list. You're being asked to calculate the average of this list. It's the same code. It may just not look like it just when it's presented like that, but an average is an average. So again, we solve it the same way. We ask ourselves, how do we compute an average? Average lenders is equal to the total number of lenders. So I'll say num lenders divided by the number of loans that were made. Okay? Now, I've written those terms, so I have to define them. I'd never leave those terms undefined, even if you just simply replace them with 0. In fact, it's often good to start them at 0, because in this case, if I'm counting up, this will be my accumulator, right? I'm going to need, what for this one, let's see, num lenders. I can't just simply pull that out of the hat. I have to say, hey, let's go and iterate over the, I need to iterate over, if I want to find out the total number of lenders, I need to iterate over this list over here. 38, 18, 3, sorry, 51, 3. Go through and iterate over this and add that all up. For the total number of loans, that's a bit easier to calculate. Num loans is equal to that variable name. Num lenders total. What a variable name. Num, I hate that variable name. Num underscore lenders underscore total. This is getting confusing now because I have this variable, which is the number of total lenders, and then I have num lender. Oh, no. Let's just call it maybe, num lenders total. So there's different ways we can go about this. We can change our variable. Another tactic you can do, though, is this. You can alias the variable. You can say num underscore lenders underscore list. You could always rename it and then use that, but let's see. To make it more consistent with whatever code you might have written, I won't do that. But you can always rename your rename variables or give them a second name, rather, a nickname, if you will. Aliasing. It's a very powerful tool. So let's go ahead. Let's say sum of lenders. Yeah. Why not? Sum of lenders. So the number of loans is equal to num underscore lenders total. I'm still not thrilled about this variable name. And asking how many loan are what's the length of that list, because that will tell me how many loans there are. So sum of the lenders is 0, number of loans, then num lenders total. Okay? And so what I need to do now is iterate over it. Like for num lenders in num underscore lenders total is equal to, and so now we're iterating over this, or let's go ahead and say n. For n, sum of lenders, and I'm just going to go ahead and do plus equals n. Right? What is plus equals? It is exactly the same as me writing this. Sum of lenders is equal to sum of lenders plus n. It's exactly the same, but that is a long variable name. This is why autocomplete is a feature of a bunch of IDEs. By by the way, if we were allowed to use, let's see what time it is. Ooh, wow, we're running low on time, so I'll go over these quickly. But if we were allowed to use sum, and by the way, on exams and stuff, if you know it in Python, you can use it. The only time where you're not allowed to use a function or something in Python is two cases. One, you have no idea what you're doing with it, right? If you can't explain it, don't use it. And the second is if I explicitly say you have to do this problem without using sum or without using this function or something. And I don't think I do so for this class. I don't think I ever do that in this class. So basically, all I care about is that does the code work? So if we were allowed to use sum, suddenly this problem becomes very, very easy, because all we would have to do is say average lenders is equal to sum of the num lenders underscore total divided by the len of num underscore lenders underscore total. Just basically the sum is the total amount divided by the number of things in there, right? You could do it in one line if you were allowed to use sum. All right, so I'm going to speed these through these next two questions, okay? Compute the number of loans made to the Philippines and store it in the variable Philippines count. Now, as I was discussing with another student, in other programming languages, it's one of those things where you have to manually go through and count. Fortunately, Python makes this super easy. Lists have a bunch of built-in functions, so we can pretty much do this in one line. So I'm going to go ahead and copy this because I'm being lazy. I'm running short on time. Philippines count is equal to, well, how would I know how many loans that were made to the Philippines? Well, what I would need to go through is I'd have to go to country name and kind of individually count the number of times Philippines occurs in country name, right? Go through and go like 1, 2, 3. So if there's a function that automatically tells me how many instances there are of a country name or instances of something is in a list, then that's going to help. And there is. So Philippines count is equal to country name dot count and that will give me the number of times something occurs in that list. Now if I do this, it's going to say 0. Why? Because there's no Philippines in the list. There's Philippines though. And of course you cannot hear the difference because you can't pronounce capital letters very easily. That's the difference. Python's case sensitive, so it does care that we put in a capital P for the Philippines. Capitalization does matter. That's kind of it's kind of an annoying quirk, and it's one of those things you have to self-enforce. So you need to be consistent about when you're naming your variables and stuff like that. You'll note that in a lot of code I write, I use capital letters I do what's called camel casing, where basically I write so if I were writing like over here, my personal preference is to do it like in Java, where what we call camel casing, where I start with a lowercase letter, then I do a capital letter for each individual different word. Python follows, most people doing Python follows the C-based way of doing it, where everything is lowercased, and you separate them out by underscores. Which one is better? Neither. It doesn't matter. What matters is that you're consistent. If you're writing a program that does underscores, then you are committing to using underscores for that entire program. Because you don't want to have to remember, while you're programming, you don't want to have to remember, wait, did I camel case it or did I underscore it? Why is this called camel casing? Because the capitalizations cause humps in the letter, like a camel has humps. It's silly, I know. All right, so over here, again, this was a single one. Philippines _ count is equal to country name dot count, the number of times Philippines occurs. And so this leads us to the last problem for the day. For each unique country name, print a line that shows the name of the country and the number of loans made to that country, like this, Guatemala 1. So this is a bit of it. So what we need to do is that we need to print out the number of times each of these appears in the list. So here's a list of all the unique country names that are in our problem. So what I'm going to do is I'm going to copy this. Okay, for name in unique countries. We're going to iterate through each of these. So we're going to start with Guatemala, then we're going to ask about Paraguay, and then we're going to solve Tajikistan, then we're going to solve Kenya, then solve Azerbaijan. Okay, so what we do to figure out the number of loans, again, is that so we're trying to figure out the number of loans that are made to each country. So how do I figure out the number of loans made to each country? We solved that in the previous problem. We ask the country name list to ask and say, hey, how many times did this name occur in the list? And so we say country name.count name. That's the number of times that it's going to occur. And then what it asks us to do, of course, though, is to print these out. Okay, so we're going to need to print out the name followed by the number of times it occurs. To do that, we'll need a print statement. And then we need to print out two things each time we print out. We are printing out those two things, and those are the name of the country. And how do I know that? It says over here, print out the name of the country, followed by a space, followed by the number of loans made to that country. So we print out the name of the country, followed by the country name.count name, the number of times that name occurs in this list. And the space, whenever you do a print comma, whenever you have to do a print statement that has a bunch of commas, it's going to automatically put spaces in between them, which is kind of useful. So that's how we solved that one. I had to go a bit faster that, and this is why I say, there's all these other fun ones to do that go over basic statistical stuff, but there's never enough time to do that. So if you want to really get some good practice on it, try your hand at these. Otherwise, if you struggle with this one, come back and rewatch this lecture and redo this exercise, because this stuff is, iterating over lists is kind of valuable. Now, before I just simply end, I'm just going to say, as far as like where do for loops land in the exam, you're going to be doing a lot of for loops with turtles, right? For loops that say, hey, you're going to get a lot of problems that say, hey, here is a picture drawn by a turtle. Write code that draws this. And you'll also have the reverse, where I give you some code and ask you to draw the resulting picture. You'll also have it, and you'll have something in between there, where I give you code with some blanks and a resulting picture and ask you to fill in the blanks. Right? So I try to be fairly fair about those, but those involve using for loops. Okay? So you will get a practice exam sometime next week, because again, it's not your exams are going to be, let's see. So we have, this is week 4, week 5, I said they'd be week 6, so they'll be on the 21st and the 24th. I'll send out an announcement about that. But you'll get the practice exam, probably on the 13th, and then I'll go over it on the 20th. I'll do a review session on the 20th where I go over that practice exam for you.